how the heck do we make this fast? And talk about inventory health, because I think I heard you curse inventory health for about 45 days while we were working on it. So I know a lot is here to make this perform like you're seeing it perform.
Yeah, that's a big topic. I and it can get a little boring. But I think to kind of summarize, um, it's a lot of little things. And I think that what the way I would sort of categorize all of these little things is, um, when you think about the work that Danny mentions, the stuff that you do to dig this data out, if it's even available, in various reports and various different tools, um, we we spend a lot of time thinking about what that domain is, what the inventory health, what is the information that you want to seek out when you're looking at inventory health. And we kind of have that well formed and well formatted in our schema, which is, just how we describe the data in our model, in our APIs. And then we do a lot of work. And I'm talking about actual compute work. We do a lot of work, figuring this stuff out in advance before you ask for it. So we are not calculating the total profit for Western Burbs when you click this button. We are calculating it, at a regular cadence every single day. So it's up to date. It's fresh. But we try to anticipate what sort of information people will be looking for and then spend a lot of time calculating that stuff in advance, computing it in advance. Um, Part of this, start talking about numbers. Part of this is us having insight into what is actually happening when people, use it. This is sort of a foundational principle of observability that I spend a lot of time talking about with my team. So I can tell you, for example, that today, we're pretty early in the morning. I think it's just after 9 a.m. Pacific time right now. We have done 1,300 different jobs, doing this computation today. It's across all our different organizations, calculating this stuff, and we're going to be doing this all throughout the day, hourly, updating these numbers. We have also handled close to 200,000 API requests. An API request is something that fires off every time, Danny does a click here, he's loading data from the server, and that's an API request that happens. I can tell you that of those 200,000 API requests, the average, amount of time it took to make that request is 120 milliseconds. And that's something that we spend a lot of time talking about, a lot of time thinking about. I know it can start throwing these numbers out and we can kind of get lost in the weeds of some technical stuff here, but I think the core idea is, anticipating what users need, computing it, spending all of that effort and time and compute time, calculating it up front, and then being really on top of our understanding of how long it's taking people to get access to this data, and how often we are calculating the data so that we can react if anything looks off or starts to slow down.
And I think that actually also touches on something that's super important about this and that care and that attention to detail that, hey, can we make these requests run in milliseconds type of thinking is oftentimes what we hear from new folks who are on the tool are it's wicked fast and it's wicked accurate. And I've tried things like this before that just don't work, right? And I think it really comes down to there's a huge amount of effort, energy, and attention that we're putting into making sure it works, right? And I think one thing that demonstrates that level of data infrastructural detail is if Danny, if you just go kind of go back to inventory health real quick, or even in this screen, just pick something like something that 383 units aged over 90 days over into the right, right? Where you looked and we were looking at those units aged type of thing. And if you just click into that view panel down there and you scroll down, what you can see is we can actually trace all the way up from showing you at this store level in milliseconds This is how much inventory you have that is aged over 90 days. And in milliseconds, you can click down to seeing the actual package level detail of how much it costs and where those units came from at the batch level that supports that top level insight, right? And the fact that we're able to do that so flexibly, so quickly, so accurately, right? um, is indicative of the fact that this is built for scale, right? Scale across not just one, two, three, or four locations, but scale across dozens of locations. And everything that we're building and every piece of feature and functionality that we build, we intentionally make sure that we can have that kind of scalability built in with the work that Eric has been doing.
And I think it can't be understated how fast this is. And we'll call back to that 14-day trial. Don't take our word for it. We're extremely confident in what we've built. We're extremely confident in where this product is at the stage of its life cycle. We're not done. We're going to talk about all the stuff we're working on, right? You're seeing all the stuff we already did before. We're obviously monitoring it and hardening it, constantly adding to it. But it works, and it works really, really well, and it performs impressively well because of the work that's put into it. And there's not a user who doesn't say that when they click through. And the reason is you're used to pulling point of sale reports, right? To get this data, you have to pull multiple point of sale reports. You're used to exporting those to spreadsheets. You're used to building custom Tableau reports, custom Looker reports, right? All these tools that are more of this like data reporting general tools. Pull this in and get your columns and your headers lined up, and then try to figure out how to pivot across them. Those things are slow. They can't do what Bob mentioned, which is understanding the domain and predicting what data you need access to, and then building that overnight and updating it every hour and caching it and making it available to you in a tenth of a second.